Welcome back. In this lesson, we're going to start talking about weather of a sort. We're still talking about the atmosphere. We're looking at the gases in the atmosphere as holding water and also moving around. So we're going to start looking at the idea of wind today. What is wind? Why does wind blow? Where does wind blow? How do you foresee where wind is going to blow and when it's not? And then as we look at the movement due to the wind of water, and a difference in heat in different places of the earth, we have all of the ingredients for weather. So this is the first lesson in section 2 that we're going to look at the properties of the atmosphere, and then we'll break it apart into a new lesson and look at some of the final properties next time. So as we talk about the atmosphere, the properties of the atmosphere, we're really starting to think about weather, because that's what is going to be happening as you have movement of heat and gases shifting. So you have the wind, blowing of the winds and moving of water specifically through the atmosphere. That is weather. So we need to think about temperature, we need to think about density, or we need to think about these things that will cause us to then understand things like wind and precipitation, etc. for later. So let's first look at temperature. So temperature really is the bumping together of particles. So as molecules bump into each other, they're going to be have a higher temperature than before. So you would normally measure, usually in science, you're going to measure in Celsius, which is a metric measurement. Kelvin is a metric. It's one of the metric thermometers that go all the way down to where molecules stop moving. That's called zero. So you can't go under zero in Kelvin. You could have zero, less than zero in Celsius or Fahrenheit, but zero is absolute zero. In Kelvin, it's where there's no molecules bumping or jittering at all. So as you go higher in the atmosphere, you're going to see that the temperature, because there's fewer molecules striking together, is going to get colder. So with rising altitude, normally in the troposphere, you're going to get cooler temperatures. Also, the air pressure is going to drop. So the air is most concentrated at the surface of the Earth. So the higher you go, the less molecules are there, and so there would be less pressure pushing down on you. So almost all of the molecules of air above you only go to the top of the stratosphere, so about 100 miles of gases pushing on you. That would be air pressure. But air pressure, say in an airplane, you have to have a pressurized cabin, because otherwise you would feel the effects of no pressure as you went that high. So also with the density of air, you're going to see that temperature and pressure and density of gases are related. So for instance, you don't put a spray can in the fire because the temperature inside that can would go higher and higher. Well, the pressure is also going to go higher, and eventually you'll explode that can like shrapnel, which is not good for the standard buys. So you're going to see that there's a relationship between pressure, temperature, and the density of gases. As you go higher, there are going to be some changes in temperature, and they're pretty easy to see since they're going to kind of go back and forth. As you go through the troposphere, the higher you get, the colder it gets, okay, because you have less molecules of gas putting it together. Once you start getting higher, though, weird things start happening. So you're closer to space, you have less filtering you. So filtering the radiation from space. So things can go back and forth as they go through these layers. In fact, these layers are called layers a lot of times because of what's happening with the temperature. The fourth layer, the thermosphere, is called the thermosphere because as you get towards space, there's little atmosphere that's blocking the sun's radiation, and you're just going to get hotter and hotter and hotter. So there's going to be inversion. These go back and forth. So they're actually easy since they do go back and forth all the way up. So if you know that it gets colder as you go higher, that means when you get to the top of the troposphere, which is called the pause, do you notice these pauses? Troposphere, tropopause, stratosphere, stratopause, mesosphere metapause. As you get to the pauses, they're going to switch. So it gets colder until it gets to the stratosphere and then it gets warmer. And then when it gets to the mesosphere, it gets colder. Then as it goes to the thermosphere, it gets warmer. So memorizable. The next concept is a temperature inversion, which is rather unusual. And it happens a lot of times in the winter. And it has to do with the cooling of the ground. So let's say that the ground has a little bit of warmth in it because of what's happened during the day. And as it dumps its heat into the air at night, sometimes you can get a situation where the air above the ground is actually warmer than the air right at the ground. And what can happen, usually what's going to happen is you're going to get fog. So let's imagine that you have a pond and the pond is cooling down because the air is very cool, especially if you have no clouds. Like a winter night where it's a perfectly clear night is a night where everybody's worried about their pipes bursting, because that is going to be seriously cold because all of the ground loses its heat and then it just goes straight up into space and just escapes. It doesn't bounce back off the clouds. Clouds can actually act like a blanket to keep the ground warm. But in the case of a temperature inversion, you get cold air trapped right at ground level, and a lot of times you can end up with fog. Sometimes if you're in heavy polluted cities, you can actually trap that pollution to where the pollution can't get away from the ground, and you can have like very high pollution days a lot of times in the winter because of the temperature inversions.